video today, I'm going to walk you through how to use Microsoft SQL Server to combine your data together. And so if you need to access any of this code, there will be a link below that will take you to a blog post that has all of this code so you can copy and paste it over to use it. But I just want to walk you through kind of the basics of how to use SQL to combine your data together. So to get started, the first thing that I want to do is create two tables, and I'm actually just going to copy and paste this over from the blog post. So with this, I'm creating a table. So up here, I have these drop tables. That's because I've already been running this and this is in the database. So I'm just removing these tables and then I'm recreating them here. So right now, I'm just creating a table called mice, and it has some of data in it. In your case, you're likely going to be bringing in Excel files, and I have a different video that can show you how to do that if you don't know how to do that already. Right now, I just kind of want to show you how to combine the data. So I just created really simple data so that we can kind of work through how to combine it. So I'm just creating a table called mice. It has a mice ID, it has a weight, a sex, and a diet, and then I'm adding in these values to it. So this is your mice IDs, your weights, the sex of them, and their diets. So the next thing I'm going to do, and this is actually inspired by a project I had where we had a bunch of data about mice, and then we did a lipid analysis on them. So we basically had two different tables, one with a bunch of lipid data and one with a bunch of mice data. So we're going to now create the lipid table just to kind of show you what that looks like. And again, I am going to copy and just paste in. So feel free to just copy and paste from that blog post if you want to work with the exact same data. If you're just interested in how to do this, give me 1 second to create this data, and we have that there. So now let's look at what these look like. So whenever you're working in SQL, you're obviously going to use select and from commands in everything you do. So the select command is asking for what data do you want it to return. So in this case, you're generally going to give it columns. So having an asterisk tells it to give me everything. And then the from is what table it's pulling that information from. And you always end SQL queries with a semicolon. So this is saying, give me all the tables from mice, or all the columns from the mice table. So if I execute, we can see those 4 columns here. And now I'm going to do the same command for the lipid table, just to give you an idea of what this looks like with a semicolon. Okay, executing this. So now we can see that we have similar mice IDs with different lipids. So if I run both of these, we can see these together. So you can see that this table is actually missing some of these IDs. So like 108 and 104 are not in this table here. And this table has some additional IDs at the bottom. And I mainly created this table to give you an example of some of the different ways we can combine data later on. So now we want to start combining this data together. So basically, we want this 101 data to match this lipid data to come in and match up with this data here. So then we can do aggregations by sex or by diet, which we can't do here because the only thing connected to this data right now is the mouse ID. So we want to create a table that joins this data together. So what I'm going to do is I'm going to do select, and I'm now going to kind of go across and pull the columns that I want. So I want the mice ID, I want the weight, the sex, diet, PC14, PC16, and these are just different lipids in case you were wondering, and PC18. And this is going to show up red because I have not given it a from yet. So I'm going to now give it a from, and I'm going to say mice. And now these are going to go away because it's like, okay, I know that these come from mice. And this is actually going to error on us in a second, and I'm going to show you why that's happening. But now we want to join. So we want it to be able to find this information to pull in. So really simply, all we have to do is say join on lipid, and then we need to tell it how it's going to join. So right now it's saying, okay, I now know where I'm pulling these from. This is going to error, which I'm going to show you how to fix in a second. So I'm going to pull from this, but how do I combine these two tables? Like, do you want this number to match this number? Do you want this number to match one of these, which it wouldn't? How do you want me to combine them? So we can simply just say on mice ID, and this equals lipid.mice ID. So this is important because if I just tell it mice ID, it does not know whether that's pulling from the mice table or the lipid table. And that's the same problem happening here. We need to specify which column is it actually pulling. And in this case, it would pull either column into this. So if we run this, finish it off with a semicolon. If we run this, see what we get. We get a table of the mice IDs, the weights, the sex, the diet, and then the corresponding lipid concentrations. Now, what you might find interesting is we are missing 104 and 109 or 108. And we're also missing this 115, 16, and 17. Yeah, 15, 17, and 19. We're missing all of that data. And so this is where we need to talk about what types of joins you can have. Okay, so I made these graphics to kind of help it make a little bit more sense. What types of joins you can have. So if you just say join in SQL, it is going to do what is called an inner join, which means if you have two tables, it will only pull the rows that have matches in both tables. So for example, in our first table would be mice. It would be the one that came before. So you can see here, the first table is going to be the first one listed. So from mice, that's our table 1, and join lipid, that's our table 2. So in this case, if it's only in the first table, it won't show up. And if it's only in the second table, it won't show up. It will only show up if it's matched in both. We do have some other options. So for example, we have a left join. This will pull everything that matches between and everything that's in the first table that doesn't have a match in the second. And we also have a right join, which is just the opposite of the left. It will pull everything from the second table, but only the matches in the first. And then the final option is a full outer join, which means it's going to pull everything from the first and second table, even if it doesn't have a match. So let's look at how to implement this within SQL. So all we're going to do is actually change what comes in front of this keyword here for join. So if we do a full outer join, and we're just going to highlight this and run it, we can see we now have null values. So these null values are saying that these rows did not have matches in the lipid table, and these rows did not have matches in the mice table. Now what's interesting, if you remember, is that the mice ID does exist in the lipid table, but it's not pulling this over because I've told it specifically to look for the mice ID. If I did look for the lipid mice ID and I rerun this, you can see now these are null because that doesn't have it. The way to get around that, and I'm just going to copy it, if you want everything to be able to see everyone's mice ID, is to actually just run everything. So the reason I'm selecting columns here is so that I don't get duplicate columns. But if I run everything, you'll see that the mice ID doesn't exist. This is the lipid mice ID, and this is the mice ID. So this is showing you that these don't exist in the lipid and these don't exist in the mice table. But we can see both of their IDs here. So now what happens if I do a left? Well, if I do a left join, it's basically going to give me this information with these nulls, but not this one. So let's look at how this works. So here you go. And why is it pulling that? So we're going to go back here. And you can see for a left, we're going to pull all of the first table, and then we're just going to pull the matches. So if it doesn't have a match, it's just going to say null there. And that's what we're seeing here. It's pulling all of the first table, and where it didn't have a match, it's saying null. And if we do a right join, it's going to do the opposite. It's going to pull all of the right, but you can see 104 and 108 are missing because they don't have matches to the right table. So that's letting you know if you want everything in your first table and only the matches from the second, do a left. If you want everything in the second table but only the matches from the first, do a right. If you just want everything, do outer. And if you want only matches, do inner. And if you just run the default, it is always going to default to an inner. So you can see here, there's no null values because it's going to default to an inner. If you have two tables that will, whatever column you're matching on, will always have matches. It does not matter what you do here. It doesn't matter if you do an outer, left, right, or inner, you're going to get the same thing. It's only when there are mismatches that you want to do it, and you want to do what makes sense logically to do. But that's the basics of how to now join this table. So I hope this was helpful for you to understand how to be able to join your data within SQL, especially if you have really, really large amounts of data. This is definitely one of the best ways to start doing it. And if you want to know how to summarize your data as well, check out this video above that will tell you how to take something like this and actually get summarization statistics on it, like your averages, your standard deviations, and your standard error of the mean, so that you can actually start visualizing and analyzing this data. I hope this was really helpful, and I look forward to seeing you in more videos so that I can teach you how to better do your data analysis for your scientific projects.